All right, you guys, this instructional video is going to go through lesson 1.1 and 1.2. All right, ladies and gentlemen, in this instructional video, you will walk through lesson 1.1 and 1.2. You'll have time to work together in your groups. And just a quick reminder, if you have your signed syllabus, please turn it into the basket today. All right, here's our learning target. You're going to learn how to identify different types of function families that a graph belongs to. And then most importantly, you're going to have to describe the graphical characteristics and create a graph to represent a particular problem scenario. Okay, you'll know you're successful. So your success criteria is if you can describe the characteristics of the function using proper vocabulary. And there's a lot of it, ladies and gentlemen. You're going to create an accurate graph of the scenario, labeling the x and y axis. And you're going to use appropriate intervals for each axis, and you're also going to need to make sure you title the graph. Additionally, you'll also be asked to solve some questions relating to this scenario. Okay, before we get too far in this video, make sure you have your Chapter 1 packet and identify the page that has all the vocabulary. So on one of the first couple pages in the packet, you'll see all of the vocabulary listed. At the end of this lesson, you'll need to make sure you go through and double check you've got vocabulary definitions written down for each one of these vocabulary terms. Okay, I want you to think for a quick second, what is a function? So think back to anything you've ever learned about a function in previous years of math. So what is a function? Okay, the mathematical definition of a function is a relation is a function if each input has exactly one output. This sometimes can be modeled on an XY table or a map, but one way to determine if a relation is a function is if it passes the vertical line test. Because we're going to be creating graphs, we will check whether or not a graph is a function by using the vertical line test. Okay, so take a second to look at these two graphs. I want to determine if these are if these are functions. So I'm going to draw a vertical line. So here's my vertical line. And if this vertical line only touches that blue line one time, do you see no matter where I slide it, it only touches the line once? That means this is a function. It's a function because it passes the vertical line test, and that tells me that each input has only one output. Okay, I'm going to take the same vertical line. I'm going to go over to this graph. You see it's a circle. If I position my vertical line here, do you see how there are two intersection points on my graph? So let me see if I can work this. So one of my intersection points is right here. The other one is right here. What that tells me is that this is not a function. This is not a function because it doesn't pass the vertical line test. What this tells me is that each input has more than one output. So using a vertical line, you can tell if a graph is a function or not. Again, this line, the blue line, only touches the black line in one spot, no matter where I put it, making it a function. Over here with the circle, all right, in your packet, look for scenario number 1 called Something's Fishy. I'm going to run through this example, and I'm going to show you what the expectations are in order to do well and be successful on this first scenario, Something's Fishy. Okay, so I'm looking at these 3 questions that are up here, and on these 3 questions, I have to make sure that I create a list of important information. I also need to create a graph, and then I'll have to answer the question that's at the end of the scenario. So what I'm going to do is I'm reading the scenario. I'm going to highlight information that I think is important. Because again, the first thing I'm looking for is just important information. So Candace is a building manager for the Crawley Enterprise office building. I don't know that any of that information is important right away, so I'm probably not going to highlight that. One of her responsibilities is cleaning the office building's aquarium. That's 200 gallons. I'm going to highlight that. For cleaning, she must remove the fish from the aquarium and drain the water. I'm gonna highlight drain the water because that means something different than, for example, like adding water. So I'm gonna highlight that. The water drains at a constant rate of 10 gallons per minute. I think that's important too. Okay, so before I do question number 2, I'm gonna go ahead and finish question number 1. So I think important information is there's a 200-gallon tank and it's draining at the rate of 10 gallons a minute. And while I'm thinking about that, I'm thinking, wow, if it's draining at the rate of 10 gallons a minute, that means the amount of water is going down in the tank. It's not increasing, it's decreasing. Okay, so for me, that's important information for me to keep in mind. So that's question number 1. I have to create a graph. So the next thing says, question number 2 says create a graph to represent the information. So I know I have to create an x-axis and a y-axis. So the independent variable or quantity, that's what I'm going to find along the x-axis is going to be my time. I'm going to measure that in minutes because it's telling me that it's emptying or draining at the rate of 10 gallons per minute. The dependent variable, is going to be water, and I'm measuring that in gallons. And that's the dependent variable because the amount of water that's draining depends on how much time my aquarium is being drained. So that's the independent dependent. So that's question number 2. I have to graph it still, but that information is going to be really important. Okay, so to graph it, I'm going to make a table, an XY table. So my X values are going to be time in minutes. That's going to be my X value. And then my Y value is going to be water in gallons. And that is my Y value. Okay. So I'm going to create a table. And I'm going to create some values right now. Oops. So here we go. All right. So if I do not spend any time draining my tank, so if the time is 0, I know that I have 200 gallons of water still left in the tank. Okay, if the tank is being drained for 1 minute, I know that I'm going to subtract 10 gallons of water, so I have 190 gallons. If the tank is draining for 2 minutes, that means I'm going to lose 10 more gallons of water, so I'll be at 180 gallons in the tank. I'm starting to see a pattern here. So if I go back up to my directions, it says I have to graph this. So I have some information that's going to allow me to graph this right now. I have my X values, I have my Y values, and I have a table of values that I can go ahead and graph. So knowing that time is the independent value, I'm going to put that on the X-axis. And I'm going to put water in gallons on the Y-axis. All right, what I'm going to do now is I'm going to go ahead and fill in my X values and my Y values along the X-axis and the Y-axis. So I'm looking at my time, and it looks like my time is small values starting at 0. So I'll start at 0 for the numbers on my X-axis, and I will likely count by 1. So I'm going to press pause and put those on my graph. Okay, so I put every other number on there. So I counted by 2s, but each line represents an interval of 1 minute. Now I'm looking at my gallons. So up the Y-axis, I'm looking at these numbers, and they're pretty big. So I'm looking at how much room I have, and I think I'm going to count by 20s to get up to 200. So I'm going to go from 0 to 200 counting by 20s. So I'm going to press pause on my video and get those values typed in. Okay, so I have my Y values plotted on my graph, and my Y intervals plotted on my graph. Now I'm going to title my graph because that's important. I'm going to just call it something's fishy, because that is the name of the scenario, but I'm going to want to make sure that I've got a title there. Center that on my graph. And now what I'm going to do is I'm going to plot these values right here on my graph. So 0, 200 means I go over to 0 on the x-axis and I go up to 200 on the y. That's my first point. And then 190, I go over 1 and up to 190. And I'm counting by 20s. So that means this is 160, 180. 190 is going to be between these two lines here. 2 and 180. So that means I'm right about here. Now my dots are kind of big, so it might be a little hard to see. But what's happening here is I'm creating a straight line that is going to go like this. So if I can connect them, kind of close there, the scenario can be described with a line that's going to look like this. All right, I've got my graph done. It's labeled. I've got a line there. I'm going to go up and make sure I finish answering all the questions. So the third question says, answer the question that is at the end of the scenario. So how long will it take for the tank to be half full? That is the first question I need to answer. Now, I can do this one of two ways. If I trust my graphing skills, which I only put 3 points on here, so my graph might not be entirely accurate, I could look at the graph to determine that, or I could rely on my algebra, which is probably going to be a little bit stronger. I know that the tank is subtracting 10 gallons of water every minute. And I know that half of 200 gallons is 100 gallons. So what I need to do is I need to do 100 divided by 10, and that's going to give me 10 minutes. So in 10 minutes, the tank is going to be half full with water. So that's the answer to my first question. Let's see if I look at my graph and see how accurate my graph is. Now, your graph might not always be accurate if you only have a couple points. So if I go over to 10 minutes and I go up, it should intersect my graph at 100 gallons, which mine does. So check your graph to see if yours also matches perfectly. You might find it might not, depending on how you put your points and drew your line in, but that's okay. Okay, how long will it take for the tank to become empty? That's the next question. So the next question is right here. Well, if it takes 10 minutes to empty 100 gallons, that means it'll take 20 minutes for the tank to be fully empty. So you're going to want to make sure you jot that down or show your work. And then what we need to do next is we need to go down and look at some graphical features of this graph. All right, so we're looking at this line here. Let's talk graphical features. Make sure you jot this down in your packet. First and foremost, this passes the vertical line test because no matter where I put a vertical line, it's only going to touch the line that I created one time. Okay, so this line only touches that black line I drew once. That tells me this is a function. What kind of function? This is a linear function. So it's a linear function because it creates a line. So look at the first 4 letters of the word linear. So linear means line. So anytime you have a straight line like this, it's going to belong to the linear function family. All right, this is a continuous function because the points are connected. So continuous means connected. The points are connected. What that really means is the time value right here can be represented in fractional amounts, such as half a minute, a quarter of a minute, 3/4 of a minute. So it's continuous because the line is connected because time can be represented in fractional amounts. And this is a decreasing function. As I trace it, so if I put my finger on top of it and I trace it, from left to right, the line goes down. Okay, ladies and gentlemen, that's your first example. This part of the video is over. You're going to have to click on the second link to get the second part of this lesson.